What we have here now is a Foxborough pneumatic differential pressure transmitter. This is a 13A, and you can see over here on the data plate, this is the model number. The output on this one is 3 to 15 PSI. There's a little more information about what the material of the body itself is, what the maximum working pressure is. There's a serial number. There's a index on what this is capable of being calibrated to, the range. Just as on the Rosemount DP cell, the bottom part of this is the sensor. That's where we're actually simulating some type of process. It's the same thing on this one. We have a high side and a low side. The high side on this one is over here. The low side is over here. Unless you have some designation on the body itself or the capsule itself, here we have an H and an L. It's kind of hard to tell which one's which on the electronic one. On the pneumatic transmitter, it's fairly obvious. There's two halves of this flange that actually encapsulate the capsule or the sensor that's in between here. The larger half, the physical half of the body itself, is the high side. And remember, we're looking at differential pressures across high side to low side. So this one, and you can see that the two flanges meet right here. Well, this is the larger side, so that is actually the high side of the transmitter. In our application today, we're going to be putting in just 0 to 100 inches of water column, so we're only going to have one piece of tubing connected up to this air fitting here. This is a little bit different than the electronic one. Well, that's a lot different than the electronic one. This is strictly pneumatics. It is strictly runoff of air. We have two more connections here, air connections. One of them, and you look right here, it says supply. This is the air supply so that this can operate. This is the output. So we can have some representative signal of the input, which equates to a certain amount of output. The output of this, like we looked on the data plate, was 3 to 15 PSI. Rule of thumb on pneumatic devices is that you take the highest output pressure, which in this case is 15 PSI, and you add 5 PSI, which will equal your supply pressure. So if we take that 15, add 5 to it, our supply pressure needs to be 20 PSI. And remember, on our calibration board, these three fittings right here have a fixed 20-pound supply coming out of them. So we would tube from one of these three air connections to the supply. The output, we said, by the data plate was 3 to 15 PSI. So on our calibration boards, we're going to connect it up to the air fitting that goes to the gauge that is scale from 0 to 15 PSI. We're going to have a lot more accuracy than if we use the 0 to 30 PSI. We're going to have more resolution. We're going to be using the majority of the gauge itself so we can be more accurate in our adjustments. The zero and span on this one, if we were simply zeroing the transmitter output, if we put equal pressure on each side of the capsule, the low and high side, if we were simply zeroing, there's a little flap cover right here that we could get to the zero adjustment. And we would simply insert a screwdriver into there and read the output of the transmitter itself and set that for 3 PSI. But we're going to do a full calibration on this, so we need to get to the inside. The cover itself is held down by 4 screws, which we'll take out. Now remember, when you're carrying these transmitters around, hold them, cradle it as you would a baby or a football. You don't want to drop this. If you come over and pick one of these transmitters up by the cover, by this part right here, who's to say that the person that had this before screwed down the screws all the way, or that they're not stripped and they just simply pull out of the housing itself? And when this thing lands on your foot, it's going to be a bad day. So make sure that you support the bottom of this transmitter when you pick it up and when you carry it around. There's the last screw. All right, here's the internals of it. Here's our air connections. Remember, this is the supply, this output. This is a relay that you're going to find on a lot of the Foxborough pneumatic devices. This is a force balance system. At the top of it here, we have a little flexure plate right here. That goes against this little nozzle. You can barely see it. It's right on the back side of this little flapper right here. That's how we get feedback out of this. This bar right here has the span adjustment connected to it. This is an adjustable fulcrum point. And you can see by this one is scaled from 20 to 250 inches of water column. So we have it scaled right here, range inches water column. We have a general idea of what it's scaled to here. This is our zero adjustment. This is the one that we were looking at under that little flap under the cover. This is your zero, and this is your span. And you'll calibrate this just like you would anything else, except you're looking for a pressure output, not a current like we've been using. So when you put in, and we're going to calibrate this one 0 to 100 inches of water column. If there's some adjustment needed on the zero, we would make that there, and we would look at our pressure gauge and make sure that it's reading 3 psi. We would apply 100 inches of water column pressure to our high side, and if we're not reading 15 psi, we would adjust our range nut here. Now the thing is, when we have air on this, when we have the supply pressure and the output connected up, there's going to be pressure on this little nut right here. Right now I can spin it pretty freely. If you have to make an adjustment on it while this thing is pressured up, simply put a flat bladed screwdriver behind this threaded bar that goes down to this bellows. Bellows is an accordion looking thing that when you apply air to it, it expands out. Put it behind the little plate right there and turn your screwdriver, rotate your screwdriver. What that will do is it will lift that adjustable fulcrum point off of the plate behind it and take the pressure off of it, and then you can move it with your fingers. It's not a real good idea, and this works, but it's not a good idea to reach up here and move this flapper. You could slightly bend that, and once you do that, you throw the entire thing out of calibration. Next, we'll tube it up and we'll check calibration on it.